Hello everyone, in today's video we're going to be taking a look at conditionals in Archean. Now a conditional is a very useful tool because it gives us the ability to make a program autonomously make decisions. Now the reason that is so valuable to us is there are so many times you're going to be doing things when you're waiting for something or you're checking for something and so on and so forth. Now the good news is conditionals inside of Archean are relatively simple to use. The tricky part of conditionals is just making sure that your logic makes sense. I know that sounds kind of funny, but if you want to have some fun, go ahead and Google Boolean algebra and get yourself a quick little reminder slash review there. It'll definitely help with understanding if it will work or not. So let's get started. So what we're going to do today is we're going to design a very basic program. As you can see here, I've got myself 4 switches. They're all in the vertical, I should say, down position, and I've got one regular switch here. We're plugged into a little battery, which is plugged into a little solar panel to make our life a little bit simpler. So I'm going to go ahead and open up my code. As you can see, there's nothing here because we're just going to go ahead and design it as we go. So what we're going to do is we're going to design a program that can tell us what switches we have on. Now, the reason we're going to do it this way is it makes it very simple to just show you how quickly you can set up logic that makes more than one decision at a time. So what I'm going to do today is I'm going to start by grabbing tick. And the reason I'm going to be grabbing tick is I want to update my logic 25 times a second. So what I'm going to do is I'm going to get the value of this switch. Now, there's a bunch of different ways, and you'll notice I labeled this one as switch 1. And you'll also notice that I set allow IO input in here. That's going to be really important for us to play around a little bit later on, as you're going to see here. So swiv 1, we don't need that. Swiv 1, swiv 2, swiv 3, and of course, I think this one is a swiv reset. So that will basically be used for the purposes of our logic. So let's do it. I'm going to first go ahead and get the value of button 1. The way I'm going to do this, though, is I'm going to keep it very simple. I'm going to go ahead, button 1, I should say switch 1, which 1 equals input number. And of course, we're going to get the switch 1. Well, this one's swa 1. So we'll keep it simple. We'll use the alias here, and we're just going to get out of 0. Keep it nice and simple. Now, folks of you at home would probably recognize right away that that is a local variable. That's good for us. And of course, it makes it a little bit easier, as you'll see in a second. All right. And we'll do switch resets just to make it nice and easy for us. All right, we're just going to power through and get all of our buttons in the positions they need to be. Now, some of you point out the fact that we could easily go ahead and basically just capture each one as input 0, input 2. I don't want to do that here. I want to make sure this is simple so you can very clearly see what's going on. So let's go ahead and save the code. Nothing should happen. We can fiddle with these switches all afternoon. Nothing is going to go bad. Now let's go ahead and print the value of one of these switches. So I'm going to print switch 1. Now the reason I want to demonstrate that is I want to point out that when switch 1 is in the down position, it gives you an integer value of 0. Now if I flip the switch on, you'll see it gives us an integer value of 1. That's important because that tells us what we need to do. So let's start with a very basic conditional, a simple if statement. We're going to say if switch 1 equals, we're going to use double equals here. Double equals simply means ask, don't tell. You'll notice we have single equals here. This is always telling. Double equals is always asking. So if switch 1 equals 1, print switch 1 is on. So now let's go ahead and try it. Switch 1 is on. Switch 1 is on. Switch 1. Perfect. Now, what you probably notice here is this is kind of obnoxious. You'll notice that it creates this nasty print down here. It makes a big old mess of everything. And that's okay because, unfortunately, we can't see where this ends. So what I want to do this time, this is a new one, is we're actually going to use the monitor to make it a little bit easier to debug our code. So at the top of my tick here, I'm going to type in something that's a little different. I'm going to type in blank black. And what that will do is convert this monitor into a black screen, as you can see here. And then instead of using the print command, I'm going to use the write command. Now, if I hit my switch this time, you'll notice on the screen, it now says switch 1 is on. If I hit the off, you'll notice that switch disappears. Now, very keen-eyed people would point out the fact that if I were to get rid of that blank black, turn the switch on and then turn it off, it will remain on the screen. So even though my logic is still correct, it still appears because we're not cleaning the screen off between runs. Now, there are much safer ways to do this. Now, that's pretty useful. As a matter of fact, we could even go further than that. We could grab our logic one more time. We could go ahead and paste this in here like this. If switch 1 equals, we'll do switch 2 this time. Now, we'll be careful here and come in here. And this will create an interesting problem for us. Can't wait. Switch 1, beautiful. Switch 2, beautiful. Switch 1 and 2. Uh-oh. As you can see, we've created a bit of a problem here. They're writing all on the same line. It makes a bit of a mess here. And if we want to fix that, of course, one of the simplest things we can do is we can go to this one and do \n. Backslash n simply says, give me a new line. So if I come in here and say backslash n, let's see what happens. Switch 1 is on, switch 2 is on. Aha, switch 1 and switch 2 are now on at the same time. And you can see it is making a big old nasty mess. Oh, that makes sense because I'm writing the new line on top of the new line. My apologies. Now, this is a bit of a mess. And what I really, really prefer here is if I could somehow put these on different lines. Now, experts, of course, will immediately point out the fact that the simplest way to do that would basically be to explicitly place them on a specific line. We can definitely do that if we wanted to. We could simply say right. Instead of switch 1 is on, we could say we want to put it at 0, 0. And now this one over here, we want to put 0, 12. Now, of course, if we do that, now we have to get more complicated because now I have to put a color in here. And it all gets a little bit messier. And it doesn't solve our original problem, as you'll see. All right, save. And you can see here clearly that because we're printing in a different spot on the screen, it's actually giving us a different command. Now, if I shut the switch off, you can see that goes off. But you'll notice here, switch 2 is now just sort of chilling with this big space above it. Now, depending on your application, we can actually benefit from this. Now, if you should at this point have a pretty good understanding of what this means to use a straight if statement. Simply, what's the thing I'm checking on the left? What's the value I'm checking for is on the right? Again, I kept it pretty simple here. Let's do something different this time. If switch 3, I'm not going to write equals 1. Now, you're sitting here going, why would you do that? That makes no sense to me. It makes perfect sense because in Archean, if you were to use just the name of the variable, if the variable has a positive value, it basically says that it is on. If it is 0 value, it says that it is off. Switch 3 is on. All right, so let's see if this works. If I hit this switch, aha, ba-ba, and you can see very clearly here that each one of those switches, the lights is coming on. That's not bad. You can see I can flip one on and off. I can turn just the third one on. Everything is looking great, and you should have a fairly good understanding of what these ifs are all about now. Now, sometimes you don't want to just quickly make a jump and then come back to the main code. This particular style, by the way, is known as what they call a branch. A switch is when you can have two possibilities, meaning if it is something, do this, but if it's not something, do something different. Let's do it. So what I'm going to do up here is I'm going to go up to my original if switch command, and I'm going to add the word else. Else is simply a way of saying, if this if is not true, do this thing instead. So if I come down here and type in right, I'll do 0, 0. Again, maximum laziness, lazy programmers are the best. We can now come in here and simply say switch 1 is off. And what you'll notice here is when I turn it on, it says it's on. When I turn it off, it says it's off. And you can see it very clearly because if this is not true, it immediately fires this statement as well. Now, if we go blink, hey, look at that. Now, of course, if I come in here, I'm going to fix my lines here because unfortunately in my effort to copy paste things quickly, I can now go ahead and turn things on and off. Now, this is pretty cool stuff, and you can do really, really neat things here. For example, I could come in here and make this a green condition. I could make this, again, if this is like an emergency switch or something like that, I could do something like that. We can come down here and make this one green. We can make this one white, and it's informational. And, of course, for this one, we'll just make it red because we can. Of course, we can come down here and we can make it, I don't know, cyan. Why not? Now, the cool thing here is you can see that we can identify the condition very quickly. Maybe switch 3 is like master arm or something like that, and switch 1 and 2, again, that would be like fuel pump. And again, you've got it all nice and color coordinated, and you can imagine how simple this would be. Now, the cool thing here is I can add more code into this. I could put a, print yay, or do output number 7 or something along those lines. Those are all quick and easy things that I can do almost instantly now that I have the ability to make quick decisions inside of my code. Now let's go a little bit further here. So since we can do this, we can also link logic together and actually make what they call compound logic. This is when you're making little statements that are basically true if something else and something else, or something else and something else, or you'll see what I mean. Now this is a cool trick because I can come down here and do things like this. If switch 1 and switch 2, the and simply means both of these statements needs to be true. So now we can have a little bit of fun here. Let's go ahead and steal one of my right statements here. Go ahead and paste that, and we'll do orange this time. Switches, switches two, what did I say, 1 and, I hadn't actually defined. We'll do 1 and 2. Switches 1 and 2 are on. And of course, so we have to fix my Spanish here. Actually, my awful English. Save. Check it out. Now notice, it says switches 1 and 2 are on. Now, if I shut this off, you'll notice that goes off. Now, if I were to turn this switch off and turn this one on, you can see that it stays off. But if I hit this one on, you will notice that this one lights up and tells me both of them are on because we're now saying and. Now, the cool thing here with and is there's another one called or. I could come in here and say if switch 1 or switch 2. I will do switch 3 here. Let's go ahead and grab this one. We'll grab ourselves a new line. Now, they're all 12 apart, by the way, if you're trying to fiddle around with this. So if I come in here and make this one a 48, I think purple is a color. 1 or 3. Now, the important thing is you're going to see this is going to cause a problem for us in a second. Nice. You'll see here, switches 1 or 3 are on. Now, notice if I turn both of those switches on, the purple stays. Now, if I shut this off, you can see my purple disappears. Now, if I hit all my switches, you can see I get a nice little cornucopia of colors here, like almost a half a rainbow. But the cool thing is, or you'll notice, is either or and. So the cool thing is if I turn both of these on, it works. If I turn one of them on, you can see that it keeps working. Now, the crazy thing is look at all these crazy conditions that we can create. Now, let's say we wanted to go a little bit further with all of our crazy switching here. And again, this is a quick little demonstration here. Let's create a situation where if all 3 switches are turned on, it says something else. So let's do that. I can do things like this. Give myself some room. If switch 1 and switch 2 and switch 3. Right, we'll do 0, 48, 54. No, that'd be 60. 60, comma, white. Why not? All switches on. Watch this. Click, and you'll see here that I have a new message that says all switches on only if all of the switches are turned on. And you can see how incredibly useful that was for basically controlling different systems on board of a vehicle. Now, the cool thing about all this logic is there's something that we're leaving out, and that's the fact that when I run this code right now, every single one of these if statements has to be evaluated. So that's 1, 2, 3, 4, 5, 6 operations immediately. Now, sometimes you don't want to go through all of these different options. Perhaps you want to set up some kind of logic that only works if the first thing is true. If not, is the second thing true? If not, is the third thing true? That is where else if steps in. Else if is an amazing trick. Let's go ahead and show you. If switch 1, let's say here, if switch 1, we're just going to go ahead and write. I'll put this in the bottom corner here. Write 0, 72, we're running out of colors here. We'll do orange. Switch 1 is on. Else if switch 2. Let's go ahead and grab my copy paste here, make my life a little bit simpler. Else if switch 3. Else all switches off. No switches are on. Now let's break down this craziness I just created. If switch 1 is turned on, we say switch 1 is on. Otherwise, we ask, is switch 2 turned on? If it is, we say switch 2 is on. And then, of course, if that one's not true and that one's not true, we try this one. If switch 3 is on, it'll press 3. Now, mathematically speaking, if none of these cases are true, all the switches should be off. Now, the reason this is so darn useful to us is we can basically chain these else ifs forever. And this is going to be evaluated only if the first one isn't true, saving us a lot of memory. All right, let's go ahead and save. Switch 1 is on. Switch everybody off. Watch this. You'll notice here it says no switches are on. That checks. If I turn on 1, switch 1 is on. Turn on 2, switch 2 is on. Turn on 3, switch 3 is on. But notice, it is a situation where if I turn on 1 and 2, you'll notice it says switch 1 because we're only checking this and only checking these if the first one was not true. So it basically gives us that opportunity to create that little compound statement like that. Now that is awesome, awesome stuff. And again, you can evaluate anything. I can say if the battery is bigger than 5, do this. I can say if you push this button, do that. Speaking of which, one of the things you probably noticed this whole time is I have this reset button that's just been kind of taunting us. And it's just kind of sitting there doing its thing. Again, nothing special, it just sort of chills. Wouldn't it be cool if we had a way that we could push that button and set all of our switches to 0? The answer is yes. And that's one of the reasons I left that button there. So what we're going to do is we're going to create a really simple check. We're going to say if input number, the name of our switch here. Actually, we don't even need to do that because we've already done it. If switch reset, we're just going to grab that real quickly here. We're going to go ahead and reset all of our switches. There we go. If switch reset, output number, Remember, because we can use the wild card here, 0, 0. All right, save. Okay, 1, 2, 3, click. Ha ha! Isn't that so cool? You can actually use switches to reset switches. Now, the reason I think that is so darn neat is that will give you the ability to hit all switches at one time. You could also use it as a way to hit all switches off at one time. Now, what I like to use that for is circuit breakers, because you could have a logic that says if you have more than this much power or something like that, kick off the switch that actually controls that power. If you're pulling too much voltage, or maybe your voltage is low or something like that. So as you can see, conditionals make your life so much simpler because you can make simple, quick decisions. Now, when I work with conditionals, of course, one of the things you want to be thinking about is remembering that your ones are going to be the ones to work. Now, one of the things I did not mention here is conditionals can have inequalities, also known as expressions in computer programming land. For example, if I created a variable number and I set it to 64, I could do things like this. If number is greater than 5. I could say if number is greater than or equal to 5. I could say if number is not equal to 5. And again, those are all options. I could say, is the number equal to 5? And all those are different options that you can for evaluation purposes. Now, one of the things I want to give you a little warning here. Sometimes they get very long. So parentheses are your friend. So I can do something like this. If number equals 64 and switch 1 equals 1, or switch 3 equals 1, print the thing happened. I don't think that'll work very well. Click. Hey, you can see that it worked perfectly. And that's important that as your conditions get progressively more complex, that you take the time and you carefully do your ands, carefully do your parentheses, carefully do your ors to make sure everything is working correctly. So you don't go, what the heck happened? Another thing I want to warn you about, you can't do this. Now, if I run this, it'll get mad at us. And the reason it's getting mad at us is if you remember a couple videos ago, I was mentioning this is how you delineate. If you do not press that lovely tab there, it's going to bust. But if your tabs come out of whack, or heaven forbid, you do something like spacebar or something like that, again, that's going to come apart on you. So you just want to be very, very mindful of that. Oh, the thing happened. This will break the code. Isn't that awesome? So conditionals are fabulous. They give us some really, really flexible tools to basically expand what we can already do. And they're also going to give us that nice little edge that allows us to make really, really good decisions. Enjoy.